Welcome to this lecture. In the last lecture, we had started discussing about the iterator pattern. The iterator pattern is a very useful pattern, and we have every Java programmer has used iterators, possibly without knowing the iterator pattern. Knowing the iterator pattern gives a insight into how the Java iterator works, and also you can define your own iterator for any aggregate class that you define. Let us just recapitulate very briefly what we were discussing in the last lecture. We said that the iterator pattern helps to provide sequential access to the elements of an aggregate object, and that the programmer does not need to know how the aggregate is stored actually internally. Just to take an example, we might have a tree, and this is a n-ary tree. We do not know how the programmer who has implemented this aggregate would have stored it. Did he use an array, array list, linked list? We do not know. We do not even have to look at the code, find out how exactly it is internally presented. If you have the iterator pattern used, we can simply call the iterator to return us one element after the other, and therefore, it makes it very easy to develop a program, to maintain a program. We can add new iterators or change the iterator without much effort. In a typical programming scenario, the programmers who are not aware of the iterator pattern, they implement the traversal algorithm in the aggregate itself. And also for the aggregate, there may be several types of traversal, and this makes the aggregate very complex, and also the aggregate has too many responsibility. Not only does it have to store elements, but also it has to support many types of traversal algorithms. The iterator pattern splits this responsibility from the aggregate object and gives this responsibility of traversal to an iterator object. So, that is the intent, to make the developer easily traverse through iteration through aggregates without knowing the internals of the aggregate, and also it helps in maintenance because the iterator can be changed easily and new types of iterators can be added. The iterator pattern helps to access an aggregate's content sequentially in a manner that is independent of the implementation of the aggregate. Whether it is implemented as a array, array list, linked list, whatever, the programmer does who wants to traverse the iterate just does the same thing, does not have to write any different code, and therefore, the implementation can be changed without the application code which requires traversal to change. The iterator supports the same interface for all types of aggregates, whether it is a tree, binary tree, n-ary tree, whether it is a array list, whatever. The same set of methods are used for traversal, and also multiple types of traversals are supported. because in many applications it is necessary to traverse the aggregate in different ways. For example, a tree may be traversed pre-order, in-order, post-order, level order and so on. We can easily have different iterators which when requested they traverse the tree in different orders. And also we can easily support multiple iterators and also multiple clients performing iterations of the same aggregate at the same time, concurrency, without affecting each other's traversal. But if it is implemented in the traversal is implemented in the aggregate, it becomes very difficult to support concurrent traversal by multiple clients. So, here the programmer irrespective of type of aggregate uses the same set of methods for traversal. Multiple types of iterators are available to implement multiple types of traversals, and also concurrent traversal by different clients becomes possible. The main idea here is that the aggregate is traversed, which is independent of the way in which it is stored. For example, we might have a tree, a binary tree, or we might have a n-ary tree, and we know what is a level order traversal of this tree, and irrespective of the type of tree, we can perform the level order traversal of the tree. It helps us to have different iterators which provide different types of traversals, and also as the software evolves, it becomes necessary to have different traversals of the same aggregate, and that can be easily done by just adding a different iterator. We do not have to change the aggregate, we just add a new iterator. In the conventional wisdom, the programmer supports the traversal algorithm along with the aggregate, which makes the aggregate very complex, has many responsibilities, a bloated interface. But with iterator we split this responsibility and the software becomes more usable and also easier to develop. Now, let us look at what are the basic methods supported in an iterator. The basic methods are reset, that is to the first element, it is reset to the beginning of the range of the elements. Next, returns the next element in the aggregate. Has next, it is a method to check if there are more elements in the aggregate. There are also additional methods depending on the application. If it is a read only application, we do not need remove, add etcetera, but then sometimes we also need to change the aggregate. We should be able to add new elements, remove elements, change elements and so on. And these are the methods supported, additional methods depending on the application. Remove, current element is removed, add an element at the current position, count the number of elements in the aggregate, and fast is sometimes supported, which is same as reset. But irrespective of the iterators used in various applications, two methods are most common. One is has next, that is whether we are at the end of the aggregate or there are more elements to traverse. It returns true if the aggregate has more elements, that have not yet been returned by the next, and next method which returns the next element in the aggregate which has not so far been traversed. In Java programming, we must be aware of some issues with the next method with the iterator. When an element is returned by a method, there are two possibilities. One is that a copy of the element in the aggregate is made and the copy is returned to the client, or a reference to the element itself can be returned. In the Java collection classes such as array list, asset, etc., when we call the next method, actually the reference is returned, and therefore, if we make any changes to the object, it will be reflected in the aggregate itself, and therefore, it becomes very easy to change the element. We do not need a separate method to change a specific element. The main idea here is summarized in this diagram with this is the example of a list, and in the list we have append, remove, and also we have the list iterator which creates the iterator. The list iterator method here the list iterator method creates the list, and once the list iterator is created, then we can have on that object have the first, next, has next, etc. invoked. So, the main classes here are the aggregate and the iterator. The responsibility for accessing and traversing an aggregate object is there placed in the separate iterator object and not part of the aggregate object. And the iterator object across various types of aggregates should have the same interface for accessing and traversing the elements, and also for various types of traversals and various types of aggregates we have the same set of methods. Now, this is the structure of the iterator pattern, very simple structure. The class structure is that the concrete aggregate is a subclass of the aggregate, and the iterator, the concrete iterator is a implementation or a subclass of the iterator. The iterator can be abstract class or an interface, and in the concrete aggregate we have a create iterator method, and as the create iterator method is called, a new concrete iterator is created. The concrete iterator object is created and the reference is kept track, and also the concrete iterator is passed a reference to the aggregate, and therefore, the concrete aggregate can traverse through the elements of the aggregate, and that is how this association relationship. One is this dotted arrow, which is the create concrete iterator, the concrete aggregate creates concrete iterator, and the other arrow is association arrow. The concrete iterator is passed a reference of the aggregate and the concrete iterator stores reference to the aggregate and uses it for traversal. The concrete iterator holds a reference to the concrete aggregate object that created the iterator. Now, the participants in the iterator pattern are the iterator, which is typically an interface or an abstract class. The concrete iterator implements the iterator interface or is a subclass of the iterator abstract class, and it keeps track of the current position of the traversal of the aggregate. So, that when the next is called, it returns the next element. The aggregate just defines an element for creating the iterator object. So, that is create iterator, and the concrete aggregate creates and returns an instance of the concrete iterator. Now, let us look at an example of the iterator pattern use. There are two aggregates here. One is an array which contains many items, and we have a linked list which also contains many items. And the array iter and linked list iterator, they are subclasses of the iterator, which is an abstract class, and the array creates an array iterator object by passing a reference to itself, and therefore, the array iterator has an association relationship with the array, where it keeps track of the reference ID, the reference of the array. Similarly, the linked list creates the linked list iterator while passing a reference of itself, and the linked list iterator keeps a reference to the linked list, the first item, next item, and so on, and that is how the association relationship is maintained. Now, what about the code? The array iterator implements the iterator interface, and it has data, and there is an index, and the constructor for the array iterator, the reference of the aggregate is passed and it just stores here, and then the index is set to 0, that is the first element. And the method first also does the same thing, it sets the index to 0 and returns the first element, and the next it returns the data of the next element. More elements checks whether there are more elements, that is index is greater than equal to data length, returns false, otherwise it returns true that there are more elements. So, the code is really simple. This pattern is quite intuitive and simple pattern. Similarly, we can have the code for the linked list iterator, which implements the iterator interface, and here there are two private data. One is the first element of the list and the other is the current element of the list, that is the first and current. And as the constructor is called, the callee, that is the aggregate, it passes the first element and the first and current are both set to first. And when the first is called, it returns the value for the first element, the next it returns the value for the next element, and more elements is just checks whether there are more elements, and depending on that it returns false or true. Now, let us just contrast the way we can use a vector without an iterator and how we write the code with iterator. Those who have done Java programming a bit, they would already be knowing this, but just for sake of comparison, we are just writing here and we will spend a minute or two on that. So, here we have a vector created and then we add elements to the vector, the first element, second element and third element, and the main code for traversal is here. In a loop, we get the size of the element, the vector, the size of the vector, and then we just get the element and then display it. That is the typical way of programming, but not too bad, because we had this method v dot element at I. But for many types of aggregates, we may not have such a method. For example, a tree which may be implemented in different ways, we may not have a way to increment I and get the element. So, the vector without the iterator is not too painful, is not too bad. We just increment I and get the element v element at I, but for tree and so on it might be difficult. Now, let us say how we traverse the same vector using a iterator. The first is we create the iterator object by calling v dot iterator, and I is the iterator object, and then we call the method I has next with the more elements and get the next element I dot next and then display that, and that is it. You can see that the code is much more elegant than the code for the one without the iterator. Now, let us look at the iterator for the Java collection classes. In the Java collection classes, we have the iterator interface, which has the has next and next methods, just like the iterator pattern we are discussing. The concrete iterator implements the iterator, and we call the iterator method, which returns the concrete iterator, and then we keep on traversing the collection using the next and has next. In the Java SDK, the iterator is an interface. So, this is the public interface iterator, has next, next and remove and so on, but then just asking that why it is not an abstract class and why is it an interface. The answer to this is that we have various types of collections, starting from array list, sets and so on, has set and so on. So, the traversal for them is very different, and therefore, we cannot define the methods in the abstract class. So, you will have to anyway override, and therefore, it just provides the template of the methods in the interface, and these are implemented by the different iterators in the different aggregates. An iterator object is an instance of class that implements the iterator interface, and the iterator interface we have already seen has the methods has next, next and remove. The Java collections, if we look, we have the set, list and the sorted set and so on, and on the other hand we have map, sorted map and so on, and the hash table is an old pre-collection class. It existed before the Java collections, and once the Java collections were defined, these were fitted here on the map, but the map does not implement the collection interface. So, these do not have iterators, and let us see how iteration in the map can be performed. So, this is a more complete diagram of the collection: set, list, queue, hash set, sorted set, linked hash set, tree set, vector, array list, linked list, and so on. And on the map we have sorted map, tree map, and hash map. So, these are the collection classes on the left side, and all of these provide iterators to create an iterator and traverse, whereas on the map we do not have a iterator, these do not implement the iterator interface. But then how does one traverse the element in the hash table? Here we do not have, we cannot create iterator object, because it is does not implement the iterator interface. Instead, it has entry set, key set, and values defined, which create set of entries, set of keys, and collection of values, and these are collections, and the set of entries, the set of keys, and the collection of values. For this we can have iterators. The basic hash table we do not have iterators, but then once we call the method entry set, key set, and values, we get collections, and for this we can get the iterator object and traverse this. So, this is the Java iterator. The iterator is defined in java.util, it is an interface, and then has next, next, and remove are the methods, and the collection implements the iterator interface, whereas map does not implement the iterator interface. On the other hand, you can get key set, values, and so on, which are collections, and you can define iterators for these, the key set, values, and so on. The uses of iterators in Java might be familiar, that we first create a list and do some operations on that, define the elements and so on. And for traversal, it is very simple using the iterator. We just create a iterator object itr by calling list.iterator, and then while iterator has next, we get the next element itr.next, and then we just process that. We can define our own iterators in a collection that we define. We might define an aggregate, and we can have iterator implemented for that. We can implement the iterator interface, or we can write our own interface here, but then please do not use non-standard interface like get number of layers, empty, get player, etc. We should use the standard terms, because that makes it easier to program consistent iterators across all types of aggregates. So, we have the iterator object created here, size, is empty, and so on. Implementing an iterator in our own application, we have many different possibilities. One is using a separate iterator class, just like we had seen, or we can make it an inner class within the aggregate class, or we can use an anonymous inner class within A. We have already seen an example of a separate class. We can use the inner class because the iterator is used only in the context of that aggregate, and therefore, it can be an inner class of that class. And the advantage of this is that we do not have to separately pass the reference to the element to the aggregate to the iterator, because it being an inner class, already has access to the private data of the aggregate, and we can also use an anonymous inner class within A. We are almost at the end of this lecture. We will just end here. Thank you.